Thank you, everyone, for joining this talk of modern data science. So I'll run you through for the next half an hour through the generative AI. And I guess in the end, you can decide whether it's a hype or reality. So I'll first like to start this talk by acknowledging first nation owners, and I acknowledge that this land that we are standing on is in the past and present. It's always been a teaching space. So today I'll first start with where we are really beyond traditional AI, or is it just the AI with a fancy name now? How generative models work, and generative models are really nothing but the LLMs. So what is there in LLMs that have made these generative models so popular? And then we'll look at how LLMs can be utilized by general public or the researchers. And I'll talk about some applications that we have developed in my research group. No fancy tools comes with the risks. So I'll just list out some realistic risks that we have so far seen by the use of LLMs and GenAI, and end up with the final message for the enterprises to use these tools. So just to start with, I thought I'll just put this slide because that's how most of us using this generative AI. So just to put the things into perspective, are you the regular user where you use these generative tools? They sound like ChatGPT, Delhi 2, Abad AI every day, or just, yep, I've tried them a couple of times, heard of it, but never used it or never heard of it. It would be good to know where you are, or for you to know where this generative AI and where you stand there. And I would have the disclaimer that I did prepare this presentation. It's not done by ChatGPT. So just to start with, AI has been long with us. It's nothing really new. 1956, when John MacArthur actually coined the term AI. But even before AI was in place in 1940s, we had a machine where it used in World War II to crack the codes and so on. 1950s, this one significant milestone where Alan Turing actually developed a test to test the intelligence of a machine. Then in terms of NLP, natural language processing or text mining, 1965 was another milestone where ELIZA, a first NLP assistant or the software was proposed that could converse with people and answer it. And I think, they have even showed in the Young Sheridan their interaction with that. 1979, when ANN term was coined by a group of researchers, and this was also a peak research time for AI. 86, Rumelhart developed the backpropagation algorithm, and that really got the AI to be par with symbolic AI, NNNs, and so on. Late 95 and early 2000 were the dark period of AI. Not much done in terms of algorithms, but later on, then a lot was done in terms of hardware. Cloud computing was done, and mobile phones and Apple were coming. And that's where then again we started to see the traction and really a most fruitful period for AI, where we saw Watson defeating Jeopardy, or AlexNet coming in 2012 and changing the game for computer vision. In the same way, we have got so much virtual assistant, like setting the pace for language models. 2015, where TensorFlow and Keras released, and deep learning became everyone's toy, whoever was in the area there, and then so on. And then 2020 kind of thing, like 2018 was the first language model, BERT, that Google brought into the picture, and that's where this generative AI kicks in. 2019 was a GAN model, generative adversarial network model, and that's where then the generative AI really kicked in. People started to play with text, play with images, any kind of data that we got. And then there is 2020 or so on, where this GPT, generative pre-trained transformer, came into the picture. And we all know 2022 November when the ChatGPT was introduced, and everything then became just so much interested for generative AI. So if we really look in this to slide, and people who are doing machine learning or statistical sciences, they would say there is nothing really new. We had generative models for the last 20 years in comparison to descriptive model. So we always have seen generative AI. So discriminative model, how they learn, they focus on discerning the classification boundaries. They would learn the features from each class to see how well these feature can classify objects into that particular class. So focus is on learning the features that can classify the boundaries most effectively. Whereas in generative model, rather than doing the focus learning, they try to understand the distribution of data. So if there are two classes, they would try to understand how does the data fit into that class. So learning the distribution now, if a new object comes in, they can actually generate a new object that mimics that description, that distribution. So if we look at right side, an example, given an image of a dog, the discriminative model would classify it as a dog or cat. And assuming that we have trained it and it has learned to classify these objects. Whereas the generative technique, it learns the data distribution. And now if we ask, how does a dog look like? It can actually create a dog image there. So now let's look into more detail that how these models are learning. So I found this thing from my lecture notes and I'm putting in there. So traditional AI, we give lots and lots of very specific examples. And this is, it could be a binary problem, it could be a categorical problem, or in terms of AI more, it's a multi-class problem. So you present the instances for each class, and then you counterpart it with giving the examples from other classes. So for example, this is a cat, this is not a cat. You build a machine learning classifier, and a machine learning classifier would now learn that, yeah, this is a cat. Whereas generative AI, you are not giving it specific examples. Rather, you are giving it research papers, textbooks, notes, Wikipedia, social media, and then you are building a model that can actually learn the probabilities, that how these words occur together, and can learn these patterns, millions and millions of probabilities about the concepts and how these words occur together. So having the same problem now, if we ask what is a cat, by rigorous statistical modeling within these models, it would learn what are the most probable words that would follow a cat is. And it would there would be a ranking, and the content that is highest ranked would be produced after a cat is. So if we see it, AI is generative AI is actually type of AI. But rather than any classification or thing, it is also trained to produce new content. based on the patterns that it has learned. So this is also about the pattern learning. It has learned the patterns, how the language are expressed. And now this pattern can be expressed in terms of generation of language, whether it's um, a translation or summarizing or question and answer. And just a disclaimer here, I am an NLP research, not a computer vision. So a lot of my examples and slides, they are heavily focused on NLP here. So even for generative AI, we have got existing content. So the data is necessary. From this data, a very large statistical model is built. And this statistical model is actually learning just the probability, maximization of likelihood that what other words would occur given a particular input words. So when you provide an input like what is a cat, it can produce this output. But when we interact this model with some prompt engineering techniques like how ChatGPT has done in the last few months, we can see the potential to drastically change the way the content is really created now. So this is an example of an image. The similar kind of thing can happen with the images as well. So a very oversimplified generative models, how they work. So we would have large amount of data, billions of text. And this text would be presented in tokens. So most of the large language model would have billions of tokens. So what is a language? So each word, what is a, becomes a token or chunks of words. So this becomes now the training data. We are not doing any fancy, just putting it as token, and we are keeping the whole sentences intact. And then we built a very large deep learning model. And I'll quickly show you how this method looks at very soon. So now, given a large piece of text data, these systems learn the patterns. So it could be how the language is expressed, or it could be, let's say, if it's abuse, then they would learn that what are the words that really point out to abuse and so on. But the thing is that this is a huge data, and then the model built is also billions of parameters. So just to give you an idea, GPT-4, it's a rumored that it has got 1.6 trillion parameters. So we are talking about that big models. GPT 3.5, whether it's a Turbo or DaVinci, it has got about 175 billion and so on. Then the Google Bard or the Palm or Lambda, they got 540 or 137 million. So essentially what we are doing, we are building a very large statistical model that learns the patterns, and then we use those patterns to generate document chat images. So this is kind of the primary training. And what made GPT-4 or ChatGPT very successful is this secondary training. So most of the time, these original models, they would be just tests to whether they are doing it correct or not. But what ChatGPT has done, they have got this test data where some of the responses generated by this language models are corrected by humans. Or ranked by humans, and then they are back propagated to this LLM model to actually adjust the probabilities that they have learned. And this step is usually called human reinforcement learning. So this reinforcement learning, along with training data, is behind the success of ChatGPT. Or whatever it can produce, or these LLMs becomes then very close to our human data. At times, this is called even fine-tuning or some specialized training. But this step becomes quite crucial to successfully use these LLMs in our purposes. So How then LLMs does. So this is a very simple example. I got it from ChatGPT. If I write, I'm making sandwich with peanut butter and. So what LLMs have got, they have got simple probabilities that would go with peanut butter and sandwich, but a lot of them. And then like this is again just the interfacing. Otherwise, some other model like BART, it gives the option jelly or jam, banana slices, honey, and so on. Because ChatGPT is trained to produce very like answers rigorously, so it just go and comprehensively expand each of the options. But most of the LLMs, that's what they do. They will print out in the ranked order the words that would occur with these combination of words. So let's see a little bit into more detail how it happens. So the building block of LLMs is a transformer. And this was about 2018 when Google produced a paper called Attention is What All You Need. And through this paper, they introduced this transformer model containing two big networks, encoder and decoder. So encoder receives the input data and process it. It would have the positional embedding, word embedding, and then many linear forward network, some of other layers, some complex network within this encoder network. But receive this source input, it actually presents a latent representation. So in a way, we can say it projects this source input data to another latent representation. And this latent representation is run through attention. So this attention is very important. So what it does is attention would give weight to each word that is occurring. And this weight metrics actually tells which two words are most related to each other. So for example, if I say, I ate green apple, so green and apple would be then highly associated because green is saying something typical about an apple. So this attention actually allows to look at all the words in a sentence or piece of text at once, and then how they relate to each other. So this is encoder model. Then we got the latent representation. This latent representation, this is passed on to the decoder, and the decoder also receives a target input. So if we are talking about language translation, so let's say source is English language, target is Hindi language. So the task is to map English to Hindi languages. So when we give this Hindi language there, we are getting this hidden representation for the input and then the output direct there that we want as an input. And now the processing happens in decoder. It maps each word to the other word or the piece of words. And now it has got the capability to generate this new sentences, or it could be something like if we write a word, then the next word occurring and so on. But this is what the basic encoder and decoder models, and and they would have the attention layers there. So this was a transformer model, and they proposed. Then there are many different kind of transformer models, and different LLMs are proposed based on different part of component of this transformer model. So for example, BART that uses these two, but then BERT, that is Google's, it only uses encoder. So what it does, it would have source and then it would generate the hidden representation. And now this hidden representation can be processed with regression or classified nodes. So we use in our work quite a lot this encoder network and do a lot of generative kind of work that I'll be showing next. Then this deco then The GPT models, they are actually decoder-only model. So, and because as many networks, as many layers you got, the more complex network becomes, the more training and problem. So that's why, so GPT kind of model, they are only the decoder based model. And if decoder, when it's an input layer, would have the capacity to generate the hidden representation of the input data. And that's how GPT do it. So how then it's used, you have an input, let's say how it's going. You got transformer model, whether it's encoder, decoder, or the combination of encoder, decoder, and like so said, for example, GPT, and then it would generate the output. So what it is trying to do, it is doing, it is maximizing the probability that this would be the output given this input. So it's a maximum likelihood of probabilities there. So why they're so spatial, the way they are being trained. So we got forward masking, backward masking, and masking. So it actually then, given the partial sentence, they learn to predict what is this. So which Sesame character would be masked. Character is your favorite. Here it is masked. Then the mask you do it. So now it knows by seeing it forward, backward, and both way to predict a masked word. A little bit more, and the positional embedding. So as such, these models do not understand that what words come in. So for example, the girl chased the fly with a butterfly net, or the fly chased the girl with a butterfly net. So they know to differentiate this. This sentence has got the girl chased the fly, this has fly chased the bird. So this one is done by positional embedding. So all these models, they have got positional embedding. They are doing this masking, and they are also using the root words. But what it does with this combination, they actually learn the context, because that's what the language model have to learn the context there. A well-known issue is hallucination. So hallucination, where it means that given an input, actually LLMs would produce some answer. This answer would be incorrect, nonsensical and incorrect, because the way, as we saw AI, when we train it with dog or cat, if we give a picture of elephant, it would still try to find which class it is closest to. So the similar kind of thing in generative AI, when you give an input, they are trained to produce some outcome. So they will do it. There are good examples that for example, like the James telescope, when in the Google, it was asked, it incorrectly answered that it took the first one to take the outer space picture. So some it could be considered as blurry JPEG or unreliable photocopier if we compare it. But again, hallucination can be solved. You have to make sure that you don't have the biased data. You learn the sufficient context, and you have given some constraint for the model to answer it. So I think the key to hallucination is how you prompt and what data you have used. So in this slide, I'll just, like the purpose is all the big players in the game. From Google to Facebook to DeepMind, Microsoft, all they are in there. And we can see Lemma was one of the first large open model, open space, because it was leaked. So Facebook then provided it open space, but Falcon AI is another open source LLMs that is available to researchers and academic to do all kind of things. LLMs are not just limited to text, like Delhi, Stable Fusion, Midjourney, imagine, we can play around with all those images as well. Very quickly, like this is what made this generative AI really very useful. Given a text, it uses this diffusion model where you reconstruct and deconstruct from noise to data. And if you write a text, an oil painting of a Bichon kind of celebrating, it would generate many images like that. Um, so how LLMs can be actually used in practice, and you can see the scale and the kind of cost associated it. So the first we are dealing with hardware vendors and so on. You have got billions of tokens and you build a large parameter. And this is, we call it trained model. So this would be your original LLM. Now, this LLM can be fine-tuned to your own data that you would like to make this LLM to be useful, or to make it some human feedback. But this is also very much resource hungry. So not many people would have even capacity to fine tuning. But if you can, there is another slice of LLMs that can be done, like for coding, medical advice, education, and then you have got this specialized model. And now you have got inferencing like ChatGPT that you can make on top of this large language model. Given a query, now you can get an answer. So the most value of LLM is actually getting when it is interacting with the service providers. Prompt design, as we have seen through ChatGPT, is one of the best way to communicate to this LLMs. So essentially, there is your LLM, and you can now prompt, for example, summarize a text of X, and it can give you the output. This has actually opened many career opportunities like gaming system, online tutorial system, and so on. So as it's rightly put by Atlantis, that talking to AI might be the most important skill of this century. So it says it's not that how you use it, but what you ask becomes really very important. The potential applications, Genai, is support bot, personalized engines, knowledge summaries, and so on. So I'll just give you some homegrown applications that we have developed in my research group. So for example, here is GPT. And these are, let's say, input 1 million documents. So this project is done with a large enterprise that has received for many, many years customer inquiries. So now how ChatGPT can use on these customer inquiries and can actually leverage the thing that LLMs provide. If you put directly these millions document to GPT and ask it to do something, from our experience, it does not give you any correct answer or specific answers. So what we have done, we have provide an application layer in between this input documents and GPT. So in summary, I would say ChatGPT is very good for knowledge generation, but when it comes to knowledge discovery, we have to rely on traditional AI models. So like in this example, what we have done, I would go through the process, but we did the topic discovery. And once we get the topics, we get top K topic for each cluster. And then we extract the top documents from each cluster. And now we have got top M documents. When we present this to GPT, actually GPT very beautifully from these documents generates the questions. And now these questions directly go into the chatbot. And now a chatbot is being developed using these questions that most commonly people have answered. So now ChatGPT, we utilize it for the question generation. Another example of how we have used ChatGPT is digitization for knowledge discovery. So we all know these historical documents. This is a Department of Resources project. And we have been engaged from last 2 to 3 years. These are these reports are coming from 1903 until now, so they have varying in terms of their quality. Some of them are handwritten, some of them are computer programs. So we did OCR and all those things, and then we developed encoder-based LLMs where we trained them to give a keyword, it extracts the output. And now when we have got this keyword and output, we can now build the dashboard like that. So these are all the mining, mineral, coals, and petroleum reports. So these reports now can be organized in this dashboard where people can query, they can find out how much gold digging has been done in Queensland and so on. So one way use ChatGPT in this project is to get these specific attributes and then get GPT to publish these results. But as I said, if we directly use ChatGPT, it does not work. But when we build a lot more knowledge discovery tools before ChatGPT, then it starts to produce these publishable outcomes. Another application that we have heavily used these language model is bias and abuse detection. So we know that these models are criticized for that they may be dealing with the biased data, but we use these models to actually produce biased outcome. And so this one, we actually innovated our own progressive transfer learning to build language model. So we saw some of the examples. Those large language models are in billions of modeling, and not everyone has got capacity to develop those large models or to consume those models. So this way, what we have done, we do not just use all the data in one go, but we progressively build the model, show one data, then fine tune it with another more specific pattern. So for example, in this one, we started with Wikipedia, then movie review, and then finally the Twitter data. This model had only the 3 million parameter, but the accuracy produced what about 97% or so. So we got this one and then fine tuned with very small label data. So now it can produce some bias and abuse. This model has been used by some commercial partners now. And the last application that I'll show is this image enhanced topic modeling. So it is an example of now how multi-model data is used, because now we know data is not just a single type, but multiple types. So when you have this multiple types data, and with this attention and the attentive heads, how we can learn that which part of image is actually referring to the text, and then developing some topic models from these data sets. So now, as an output, we do not just see the topics or the words, we can actually also see the images that are part of these topics. So this can be used multiple many ways. So it's so all good about some of the risks that we can see: violation of data privacy. There is really some confusion as in what data is being used. So for example, if we talk about ChatGPT, it's still people say that they even use LinkedIn data. So let's see what happens. So it depends upon what data is being used. And very violations of intellectual property. So if you check the term of services, will your inputs or prompts be used as training data? There is a very blurry line there. Because when you create the account, it does say that it may use it. Violations of academic integrity. If you have used, especially if not a lot of information is available on a, like especially it can happen on scientific topics. If you ask a very peculiar question and if does not have much data, it actually produces answer only from one source. So do a spot check of some outputs using a search engine, and you can see if any are wholly from another work. Um, Training data bias, we all know about the AI data bias. So the same problems are inherited by the generative AI systems. Lack of creativity or innovation, like the mediocre content that we all know. Glitch tokens are another thing that many of now, like that's where now the spamming and all those things would occur, that people are actually intentionally designing malicious prompt to malfunction LLMs. Hallucination, we already saw this, and if I see a biggest risk that in few years' time, the web would be overrun with AI generated content, and it would become really highly distinguishable that which one is human generated and AI generated, and people will use it to game the algorithms. Um, some of the ChatGPT issues, for example, it is programmed to avoid certain kinds of contact. That's a good or bad in way. Unaware of current events, like at least the free version, nothing comes after September 2001. So it's not a real-time system. Has built-in bias, like in here, tell me a joke about women, I won't. Tell me a joke about men, it would. ChatGPT requires highly detailed instructions. You have to really come up to many times to do the current quick prompt. As I said, mediocre and suffers from hallucination. So there is not really any novelty or creativity because it's everything that is given to them, it can only generate based on that. Um, so how do enterprises really use this kind of systems? And as we call it, Gen I paralysis, it's a powerful new primitive, but how to use it is not so obvious. And the another thing to take care that all while preserving data security. So you want to use ChatGPT to build application on your data, but you don't want to release it on. So it's not an easy task. It can be done. But the most important thing is that you have to really understand which use cases would be most effectively tackled within your organization, and which really demonstrate the fast success and cultivate. And the another thing is, what skills have you got in your organization? So for example, these systems can be used by three ways. Model development. So like in one of our my application, I gave you an example where we started from scratch and we come up with our own large language model or language model. The other common way is model specialization, where you use the large language model, but then you specialize on your data. And the third most easiest, cheapest, fastest is prompt engineering, but you don't really have that much control what's happening with your data. So it all depends upon where your skills is in terms of your organization, and then you utilize it. So as a final remark, I will say that Gen IEs are great for productivity. They can be nifty shortcuts, especially to jumpstart creativity. But they should always be used and taught to be used with a critical mind. They are prone to mistakes and hallucinations. So it's important that you consume these models with some guardrails. That's the current trend is consumer poses a query, you have some guardrails, you check, and you make sure that it's within your organization. Interact with LLMs, it gets the request, then response, you check again, and then you go back. And I'll finish it in on a positive note by Bill Gates that in the next 5 to 10 years, as he said in 2 years back, AI-driven software will finally deliver on the promise of revolutionizing the way people teach and learn. And it would really give us much more personalized way to consume the information online. Thank you, everyone, for listening to me. And now we can open it for question and answer, Gentry.
Great, thank you, Richi. That was really interesting. My guess was going to be that Bill Gates quote was from 2016.
Yeah. So
just because that seems to be the way everything is. About 10 years, about 10 years from now, everything's going to happen.
yeah, exactly. I think
We're
this is
we've been
really
10
good
years
one.
away from self-driving cars for about 30 years now. Um, no, thank you very much for that. It was a very interesting talk. I'm going to open the floor for other people. I have lots of questions, but I'm sure other people do. So I'm going to go ahead and open it up and tell people to feel free to just chime on in if you have a question. Yes, go
So
ahead.
I'll go first then. I raised my hand as well. I don't know
Yes.
if you're going by that. Gentry, hi, Sanders here,
Yep.
back in Canberra. Thanks, Rishi. That was a very, very good talk. My first question would be whether I noticed a number of links that I would be curious to click on in your presentation, whether those could be shared. That would be really good. And then I kind of thought your last quote there with Bill Gates. I mean, he's been both right and wrong. So it would be cool to, run some kind of model on what he's been saying the past 20 years or something like that, just out of curiosity. But we'll see where that lands. My question is a bit of a paradox, and I hope I will make sense with it. But it's kind of things I've been thinking about in this space for quite some while, being a trained statistician with probability theory and so on. In these models that are huge, right? They're massive. I mean, the amounts of data is just horrendously big. It's incomprehensible in many ways. One of the things I've been thinking around in my training, and the paradox I feel around this, is the paradox of size here. I mean, there is probabilities. Probabilities are based on estimations on frequencies and so on and so forth. And what I've been thinking around is there any studies or work around the marginal added value? I mean, if you have like billions of parameters, what's the added value of the last million that you add to this? I mean, obviously, the more you train, the more it will cost. You had a slide there saying, it will cost this much to train and so on. So what's the current research? What's your views on these, if it makes sense? My question is basically looking for optimal solutions, trying to make this a little bit more efficient. And what's the, why would you kind of drown things? Does it really matter? Do you have to? And so on. And the other one, is there a current research field? I'm sure there will be or is already, but is there anything around that we come that you're aware of? If that question makes sense.
So that's what it's happening. These organizations, they are using more and more data and covering more and more of the field. And that's why it's becoming such a big LLM. So they are trying to do kind of like one model fits all. And when it goes one model fits all, then they are doing this billions and billions of parameters. But now, and then there is the way that you do slicing and dicing or distill. And that's where then the small parameter. So for example, like Falcon, they have got one very big 400 billion something, then the smaller one is 47 million. So then some organizations can use those smaller ones. Again, it depends upon like how specialized use you have got for LLM. So a lot of organizations, if they are, for example, like they know they are only going to use it for medical use, then they don't have to really include all other domains there. But these organizations, because in the race to cover as broad as they can be, they are just going for these billion parameters. So I think there. So that's what, like in one of my research that I shown, like we actually got away doing only with 3 million parameter model. It was not really necessarily needed that big model because it was just for some particular application. So I guess that would be my answer to your first question. And there has been now a lot of studies happening, like the trade-off of these models. And actually just recently, last week, a study came that they did, and they said ChatGPT answers are not so highly correct. They are just the mediocre. but normal people think that they are good because it can just solve the general purpose problems. So I think these are now the research, a lot of research is happening in terms of their trade-off. But they are progressed so fast. Like for example, this Facebook llama, like it came and within 48 hours, Perplexity AI create this llama chat. And it is shown that they can produce little bit better than the ChatGPT.
Great, great. Thank you. I think that was a very good answer. I hope, Anders. We'll move on. I think next up we'll have Aiden. You go ahead and ask your question.
Hi, thanks very much, Richi. Great presentation. It's good to hear, I guess, from the perspective of a researcher in the field too, some of your thoughts around risks and whatnot with generative AI. My question maybe jumps into that opinion space, where I was originally going to ask you questions about where you see academic integrity going in the future, because as generative AI continues to improve, there's going to be pretty significant changes that are required to make sure people are in fact skilled. But then I thought maybe a more relevant question with ABS folk around would be something to do with the long-term impact on what I will call general workplace skills. So things like general communication, the ability to write an email or reach out to somebody, or something relevant to me, which is general menial, I guess, data science work like joining, cleaning data, that kind of thing. Do you see that this stuff will just not even matter in the future because it will be something that's almost entirely AI handled? Or, yeah, your opinion on that would be great.
Yeah, like if I really talk about like how now like few things that we do, for example, like use of this word processing tools where we just write it and do not worry about the spelling mistakes that we know the system would automatically correct it. So it has just, we have now grown to that. The another thing is calculators. We just use calculator for some simple calculation without even giving a second thought that we could do it. Or like I can still do some because in my age, like I have been taught tables and kind of by hands, but the younger generation, I would not think it. So if we think about in that way in future, some of the tasks that we do, we would be just asking these assistants. So I think in future, ChatGPT like things would become like Siri or Alexa, how we ask them to do some specific task. But these tools now would start, we would just say, write an email and they would just, we'll give a few words and they would create this email and we would trust them. It would become a everyday practice. So that's how at least I see as an, especially in the field of text mining and the NLP, this would become everyday practice to use these tools.
The note of the calculator and whatnot is yeah, very insightful. Thank you.
Great, thank you. Edwin.
Yeah, hello. Can you see me?
Yeah.
Yeah. Thanks for the interesting presentation, Richie. So my question, I don't think it really has a right or wrong answer. I'm just interested in hearing your view about this. So often when we talk about machine learning and deep learning and AI, it's often helpful to categorize those methods as, whether it's supervised or unsupervised or reinforcement learning or so on. Just in your view, with generative models, which does that fall under? Would you consider that supervised?
It's completely unsupervised.
Completely
So
unsupervised.
when we give all those text collection, we do not label it at all. So essentially, automatically, like the next word would become its own label. So when I'm saying, oh, a young girl is running, if I say young girl and I'll mask running, and that word becomes implicitly a label to learn that this is the word following this piece of text. So language models are completely unsupervised training. But as I shown in one of my slides, that is a primary training. So primary training is always unsupervised, but the secondary training, when we fine tune, so for example, human data. So now these models has provided us some answer. We rank them or we label them yes or no, or rank 1 to 10, and then we feed back again to the model as a reward or penalty. So that's a reinforcement learning part of it. Mm, but by default they are unsupervised trained, and that's why they have become so popular, because there is no labor. You can feed any data, social media data, any textbooks or anything, without worrying about finding the labels.
Okay, thank you.
Great, great, great. Claire, I think you're up next.
Hi, Claire.
Thanks, Gentry. Thanks, Richi. That was a really good talk. I've been involved with a few discussions with other national statistical officers about the uses of large language models. And I guess one of the concerns that we have is that when we see information being used or being provided by these models, that we would prefer it be our information. So, you know, if people look up like what's the CPI of Australia, that information comes from the ABS. So your talk seems to suggest that in order to get that kind of information sort of attached to a large language model, you need kind of additional sort of infrastructure. Would that be your sort of thoughts in that kind of case as well, that we would actually probably have to put something together that said, you know, this is ABS GPT if you want to come and ask about ABS statistics or something like that?
Yep. So that would be fine tuning. So you use LMA, any large language model, and then you got your own documents and you fine tune on those documents. So now, in a way, you have made those LLMs biased to your data. So when they answer any question, it would be in consideration of ABS data that we use. So a fine tuning in a way is adding bias to your like different kind of bias, not the bias, but yes, some specific answers there. And again, in terms of like how much data you want to use that for fine tune, whether it's just a snapshot and then it goes and it's your own. But if you want to have certain control, then you use these LLMs, because you don't want to use a LLM from scratch. This is like, as I said, the first phase is not really needed. But the second phase, where we can use some distillation of the LLMs or some smaller level of LLMs, and then fine tune with your data to make it much more specific.
Okay, thank you.
Great, great. Any further questions? Then I'll get to ask questions.
There is one in the chat. There's one in the chat as well, Yantri.
Oh, is there? Oh, okay. Yep. Good. Okay, so Erica asked, why do newer LLMs have orders of magnitudes more parameters? Do these parameters represent the individual conditional probability of a word/token appearing given its surrounding words in either direction? Or are the additional parameters being added in the hidden neural network layers? Or is it all a bit opaque and mysterious as to what the additional parameters represent?
Yeah, these are the pure black box. We don't really know what's going inside. So I don't think so. Like, of course, there is some proportion as to the size of LLMs and the size and the nature of the data that we want to learn. But nowhere that these parameters ever reflect individual words. So it's not. But as we go more and more layers, that's where they are trying to learn the abstract knowledge in the data. And then as we go towards the end, that abstract knowledge is converted into more conceptualization and a more refined model. So I think the more and more layer is something like that, uh, there, like the more words occurrence, the more relationship is being created. And now we are like we are making this LLM to do even the language translation. So we are assuming that given any language, it would also translate other languages. So for example, some earlier LLMs were limited to some constrained languages. Now we have got more documents coming from other languages. So then it is trying to learn the relationship or the characteristic of that particular language as well. And those things are learned through the connections. So those connections are then created, but it is not really ever one-on-one connection.
So the answer is no.
No.
We don't really know what those
They are.
parameters
Yeah,
are.
it is really a black box, but I can say for sure that a node or a connection is never representing a word directly.
Yeah. Okay. Well, thank you very much, everybody. Those were some actually very, very interesting, thought-provoking questions. We're out of time now, so I think we'll wrap it up for this month, but we'll be back next month with another topic.
Thank you, everyone, for listening here. Thank you then. Bye-bye.